Welcome back. In this section, we're going to recreate the process of building an end-to-end machine learning pipeline as it happens in the research environment. In the research environment, the data scientist has the freedom to investigate, analyze, and then develop a model that hopefully will add some business value. I want to bring in the concepts that we discussed so far that we need to consider when developing software, like reusability, reliability, and reproducibility, and how we can tackle these principles already in the research environment when we start creating our models. We will discuss the use of open source and what happens when the tools that we need are not available open source. And then I will summarize what we're going to find in the rest of the section. We mentioned that a typical machine learning pipeline involves steps of gathering the data from different data sources, then transforming that data in various forms to tackle the quality of the data or to create new features. Then we can select the features that we want to use in the machine learning models. Then we finally train the models, obtain the predictions, and evaluate model performance. We mentioned that we need to deploy the entire machine learning pipeline and not just the machine learning model, because what we need to have in the production environment is a complete sequence of steps that takes in the raw data and outputs a final prediction. We also discussed the concept of reproducibility, which means that the pipelines in the research environment and the pipeline in the production environment should be identical, or in practice as similar as possible, and this means that given the same data, they should produce the same prediction. And we also discussed the other principles that we need to consider to create a model that will be deployed, like reliability, reusability, maintainability, and flexibility. We mentioned that open source increases the performance of the data science team and also the developing team, because open source offers code that is ready to use and very often off-the-shelf algorithms that can take the data in and produce the predictions after training. They maximize reproducibility because typically open source is versioned and we know exactly what is contained in each version, and we can actually install different versions depending on needs. And open source also supports reliability because the classes available in the software are tested. We can of course install open source across different systems, and different data scientists can get hold of these libraries. Therefore, open source is reusable and it has a dedicated team that maintains the software as well. Altogether, this means that with open source, we can minimize deployment times. So what happens when we need to transform our variables or train a model that is not available in a Python library? In this case, perhaps the best solution is to create in-house software. You may wonder why. Well, for various reasons. First, if we create software, we will automatically version our software, which means that as we maintain and develop the software, we can increase the versioning so we know which version we are using in each machine learning system. When we build in-house software, we will usually add testing, so we know that the output is the expected one. Various users can install the software that we build in-house, and it can also be installed across systems, therefore it is reusable. And because all of these reasons, building in-house software and sharing it across people and teams minimize deployment times, as well as the model development time. So with all of this in mind, in this section, we're going to follow 5 steps. In the first part of the section, we're going to give you an overview of the different steps of the machine learning pipeline, including what feature engineering is, what feature selection is, and how do we train models. In the second part of this section, we're going to create an end-to-end machine learning pipeline. Then we're going to discuss the available open source packages for feature engineering, feature selection, and model training. Then we're going to discuss the creation of in-house software for those transformations that are not available in open source. And finally, we are going to optimize the pipeline utilizing now the open source and the in-house packages to leave the model almost ready to be integrated into the production environment. With this said, let's move on to the first part of this section, where I will discuss the different steps of the machine learning pipeline.